This is not a prop from a fantasy movie. It is not made of plastic. It is not a digital illusion created by a visual effects artist. Sitting on this reinforced wooden pallet is a single vegetable that weighs more than a grand piano. Hivleet. It is heavy enough to crush a small car. It is dense. It is cold to the touch. And Terra. But look at the map. We are not in the humid tropics. We are not in the fertile fields of California. We are in the Matanuska Valley, Alaska. A subarctic frontier better known for glaciers and permafrost than agriculture. Time is the enemy here. In the world of agriculture, size usually equals time. To grow a massive oak tree, you need decades. To grow a prize-winning watermelon in the American South, you need a long, lazy summer that stretches for half the year. But Alaska does not have time. The growing season in the Matanuska Valley is brutal. It lasts roughly 105 days. Logic dictates this valley should be barren. For centuries, this land was considered too hostile for serious farming. The soil is a mix of glacial silt, fine as flour, dense and cold. When the first colonists arrived here in the 1930s, part of the New Deal to settle the frontier, they struggled. So why are we seeing giants? If you walk through the State Fair in Palmer today, you don't see stunted, struggling crops. You see 130-pound, you see broccoli the size of small trees. And dominating them all, the pumpkins. There is a hidden variable in this equation. Something we are missing. It's not about how many days the plants have. It is about what happens during those days. The secret is in the sky. If you look at a globe, the Matanuska Valley sits at 61 degrees north latitude. In December, this location is a tomb of darkness. But in June and July, the Earth tilts, the midnight sun. During the peak of summer, the sun barely dips below the horizon. It sets at midnight and rises 3 a.m., but the sky never truly goes dark. For a human, this constant light is exhausting. But for a pumpkin, it is an unlimited fuel source. To understand why this creates giants, we have to look at the basic engine of plant life, photosynthesis. In a normal field in California or Mexico, a plant works a shift. During the day, it collects sunlight to convert. But at night, the plant has to pay a tax. When the sun goes down, photosynthesis stops. The plant switches to respiration. It burns some of those sugars just to stay alive and maintain its cells. It's 2 steps forward, 1 step back. In Alaska, the factory never closes. Because the light never truly fades, the photosynthesis engine runs on overdrive for 20 hours a day. Plants. The plant does not get the signal to sleep. it does not switch fully to respiration mode. It just keeps making sugar, hour after hour, day after day. The result is a biological surplus that the plant has to dump somewhere. It pushes all that excess carbohydrate into the fruit. The growth rate becomes explosive. At peak season, these pumpkins aren't just growing, they are inflating like balloons. A prize-winning pumpkin in this valley can pack on 40 to 50 pounds in a single 24-hour period. That is 2 pounds every hour. If you sit quietly in the field next to one of these giants, local farmers swear you can actually hear it happening. We are witnessing a plant that is essentially force-feeding itself on sunlight, expanding at the absolute physical limit of its cellular structure. But this unlimited energy comes with a dangerous price. This kind of growth is unstable. A pumpkin growing 50 pounds a day is a ticking time bomb. The skin is under immense tension. If the fruit grows too fast, faster than the skin can expand, it explodes. A single split in the rind, even a hairline fracture, disqualifies the pumpkin from competition. They have to nurse these monsters. Every night, when the temperature drops, they cover the pumpkins with thick wool blankets, not to comfort them, but to keep the skin elastic. They prune every other fruit on the vine, sacrificing hundreds of potential pumpkins so that the plant pumps every ounce of water and sugar into just one chosen heir. They inject nutrients directly into the soil, creating a bespoke cocktail of minerals to support the structural integrity of the giant. And they are constantly fighting the one thing they cannot control: the impending winter. By late August, the race is frantic. The pumpkin needs every minute of sunlight to hit that 1,000-pound mark, but the frost is hunting it down. It is a high-stakes gamble between the unlimited solar energy of the Arctic summer and the lethal cold of the Arctic winter. When harvest day finally comes, you don't pick these vegetables. You rig them. Easy now, easy. Watch the left side. Bring it down slowly. The moment of truth is simply a number on a digital display. But that number represents a victory over geography itself. So what is the point of a 500-kilogram pumpkin? Culinary speaking, they are useless. The meat is tough, fibrous, and bland. You cannot make a pie out of a monster. Look at this absolute unit. All the hard work paid off. This right here is the proof of concept. The Alaskan giant proves that the biological limits we see every day, the size of a tomato, the weight of a squash, they are just habits. Enter. They are the result of normal conditions. But when you introduce an anomaly, like 20 hours of relentless sunlight, this vegetable is a living reminder that nature is not a static painting. It is a dynamic engine. In the frozen valleys of Alaska, the sun didn't just grow a pumpkin. It revealed a secret about the hidden capacity of life itself. In the end, the Matanuska giant teaches us that our definition of reality is fragile. It only exists because of the specific conditions we are used to. Change the latitude, change the light, and the familiar becomes the alien. Welcome to Terra Anomalies.